right along to question 7. Right. Let's try red. Red is a bold color. And we're going to write the equations down again. We have EH equal to MCAT. We have EH equal to MLF. EH is also equal to MLV. EH equals to PT. EH equals to MV squared over 2, and EH equals to MGH. Okay? Don't forget that is gas to liquid and liquid to gas for this one. This is LV, and this is LF, where you have solid to liquid and liquid to solid. How much heat is needed to change 4 grams of water at 100 degrees Celsius to steam at 100 degrees Celsius? That's A. And then B, find the heat given out when 10 grams of steam of 100 degrees Celsius condenses and cools to water at 50 degrees Celsius. So these are supposed to be fun. So let's start with drawing. So we're starting with 4 grams of water. And we have 4 grams, and it's at 100 degrees Celsius, and it goes directly to steam. So there's no temperature change, there's only a phase change. Okay, so this is 4 grams of steam at the same 100 degrees Celsius. And in B, we have 10 grams of steam at 100 degrees Celsius, moving towards a liquid state. So we're going backwards. And remember, if you're going from gas to liquid, there must be a change in phase. So we're going to go to 100 degrees Celsius of water, and then we're going to move right on into the cooling stage, where it is changing temperature now at 50 degrees Celsius. So we have our drawings complete for A and B. So for A is a bit simpler than B. It's less calculation. So we know there is no temperature change, so we're not going to use MCAT. However, we're going from a liquid to a gas, and we finally reach to this section, liquid to a gas. So we're going to use MLV, okay, liquid to a gas, and therefore you're going to have EH, the heat that's given off here, so the heat that's taken to break these bonds. You have 4 grams, which is the mass, and then 2300 joules per gram. The grams cancel out, so you're left with 2300 times 4, which gives you 9200 joules. Okay? And then we have here that, so this is the end for this one. That's it. And then for this one now, it says find the heat given out on 10 grams of steam at 100 degrees, condenses and cools. So we need the heat given out, right? So we're going backwards. So we have A and B to solve. Since this is no temperature change, we're not using MCAT. So this is a temperature change here, we know we're using MCAT right here. But for this one, we're using mass times the latent heat of vaporization. Remember, gas to liquid or liquid to gas, we use latent heat of vaporization. So for A, we have EH equals to MLV, and that will give us 10 grams times 2300 joules per gram. That cancels out, and we end up with 23,000 joules. And then we have B, where we have the EH is equal to the MCAT. And look at it, you have 10 grams, making sure I have my mass correct, and 4.2, because we're dealing with water, joules per gram degrees Celsius, times the temperature change, which is 100 minus 50. And we end up with 10 times 4.2 times 50. We end up with 2100 joules. So the total heat given out to achieve this change in phase and change in temperature is 25,100 joules. I hope everybody got that. Okay, that's the end of question 7. So moving on to question 8. See the nice color right here, orange. I don't want to write back the equation again. I'm telling you, I'm on a mission to get you to remember this. So we have MCAT and EH equal to MLF, and then EH equal to MLV, then EH equals to PT, EH equals to MV squared over 2, and then EH equals to MGH. Again, this is from gas to liquid, and this is from liquid to gas, LV, latent heat of vaporization, and this one is latent heat of fusion. We're going from solid to liquid in this case, and liquid to solid. So it says a 3 kilowatt electric kettle is left on for 2 minutes after the water starts to boil. What mass of water is boiled off in this time? Okay, so we don't have any temperature change here, so we're going to be using EH equal to PT. Okay, so say we have P, which is 3 kilowatts, translated as 3,000 watts, which is also 3,000 joules per second. We have time, it's 2 minutes, but we need the time in seconds, and since 1 minute is 60 seconds, 2 minutes will be 120 seconds. And then we need the actual mass, so we're looking for mass, which is X. And so since this is after the water starts to boil, so we're going from a liquid to a gas in this case. So we're doing latent heat of vaporization. So we have water. If we draw it out here, we have water. They won't give us that. So we have water at, let's just assume 100 degrees Celsius, and it's transformed, because it's boiling now, into a gas at the same 100 degrees Celsius. So it's a temperature change, and if we're going from liquid to a gas, then you're dealing with latent heat of vaporization. So in this case, we have LV, which is equal to 2,300 joules per gram. Okay, so we say looking for mass. So in this case, we say EH is equal to PT, where the EH represents MLV, and then we have PT. So if we solve it for mass, we should divide both sides by LV, and we have M is equal to power, which is 3000 joules per second, times time, which is 120 seconds, divided by 2300 joules per grams. And we're going to pull out the units underneath here so we could see. So we have joules per second times second over 1 times G over J. So the J cancel, the S cancel, and we're left back with grams, which means we're going in the correct direction. So 3000 times 120 divided by 2300, and that will give us 156, well, let's run 157 grams of water. Okay, good. So that's question 8, it seems like. Alright, and then now we're moving on to question 9. Let's use another color, keep you awake. Let's go with yellow again. So I'm going to write the equations here. Yes, my mission shall be fulfilled. Of course it will be MCAT. And then we have EH equal to MLF. Then EH equal to MLV. Then EH equals to PT. Then EH equals to MV squared over 2. Then EH equals to MGH. Awesome sauce. And remember, we went from gas to liquid, and from liquid to a gas in this case. This is LV, and this is LF here. We're going from solid to a liquid, and from liquid to solid. So if a 500 watt immersion heater takes 34 seconds to melt 0.05 kilograms of ice, what is the specific latent heat of fusion of ice? Okay, so they'll give us in kilograms. So let's just list. So we have power. They didn't mention any temperature changes here. So we have power, which is 500 watts, and that is equivalent to 500 joules per second. Then you have a time stated, which is 34 seconds, is in the correct units. And then you have the mass of the ice, which is 0.050 kilograms. And since we're in grams the whole time, you could have it in kilograms, by the way. So maybe I could work it out in grams and kilograms for you. So in grams, you just divide by 1000. And let me make sure. Sometimes I forget it. So 1 kilogram is 1000 grams. Yeah. Oh, so you multiply by 1000, my bad. So you multiply by 1000 and you should get 50 grams. Right? And then from there, what else do we have? What is the specific latent heat of fusion of ice? So we know that at some point, so we're going to do I'm going to do part 1 in grams. So we're going to look for LF in units in JG, and then 2 we're going to look for it in JKG. Okay, so in JG we know that power times time will be equal to MLF, because remember EH could be equal to LV or MLF or MLV. In this case, looking for the fusion, and so we looking for LF, so therefore it will be LF equals to PT over N. So how I got that done, I just divide both sides by M and I just switch it, LF equal to PT over M. So LF in JG, in J per G, in joules per gram would be 500 joules per second times 34 seconds over, and G looking for distance of 50, and the same setup goes here. So we're going to use LF equals to 500 joules per second times 34 seconds over 0.050 kg. This will give us the actual SI units. These are just units that you can use on the cells. They're not standard, but they are accepted. Times 34 divided by 50. So we get back the same number. Alright? And seconds cancel out, you end up with J over G. With this one you might get, I think, a bigger number you're going to get. So you have 500, but you're going to have the same numbers. Just going to be a bigger version of it. Times 34 divided by 0.05. And that gives us 340,000 joules per kilogram. So it's the same set of numbers, it's just extra zeros. Alright, so this is the actual SI unit. So you would see this more. This right here, is the actual SI unit. And so you would see this number being presented in books more. This was just put here so that we could work out our questions neatly using grams, because most of the questions have grams, right? Okay, so moving on to question 10. There is always light at the end of the tunnel, guys. We're soon there. We're gonna use blue. Okay, so writing back the equation right here, EH equals to MCAT. EH also equals to MLF. EH is equal to MLV. EH equals to PT. EH equals to MV squared over 2. EH equals to MGH. Great. So we have that. Remember, this is gas to liquid and liquid to gas. And this represents LV. And this is LF right here. Solid to liquid and liquid to solid. Right? So it says a 1 kilowatt immersion heater takes 450 seconds to boil away 0.200 kilograms of water at 100 degrees Celsius. What value does this give for the specific latent heat of vaporization of water? So they are correct. So we're going from water at 100 degrees Celsius to its counterpart, steam, at 100 degrees Celsius, right? So we're definitely dealing with MLV. And the water is 0.200 kilograms, which is also 200 grams. Okay, so we're going to do the two calculations to see if we get this number back in joules per grams, and then we're going to want to show the number we should expect in joules per kilograms. So let's write all that we have done. We have power. Anything watts is power. So power is 1,000 watts. We're converting from kilowatts to watts, and then that's 1,000 joules per second. Remember, 1 watt is equivalent to 1 joule per second. No mouse getting lazy. And then what else we have? We have the time, which is 450 seconds. We have the mass of the water, which is 0.200 kilograms. We also have it at 200 grams because we want to work out 1 and 2. And then we want to work out LV. So LV is what we want to solve. So remember, power times time is also equal to MLV, and we're going to do we're going to use 1 with the grams. So if we're solving for LV, we have to divide both sides by M. So therefore LV will be equal to PT over M, and that will be 1,000 joules per second times 450 seconds divided by the mass in kilograms. So this will give us our actual SI unit and the value for that SI unit. And for number 2, we're going to do it in grams. So that will be PT over M, and we're going to have 1,000 joules per second times 450 seconds divided by 200 grams. Okay, so when you work it out, you should get this number right here for this one. So you get 2250 joules per grams, and if you round that up, this number will pop up this, so you will end up getting 2300. So to the nearest 100 right there, and then this one will give us a very large number, 2,250,000 joules per kilogram, because the seconds will cancel out, right? And so to the nearest, what is this, 100,000 to nearest 100,000. Have that joules per kilogram. My God, just gonna bump up that. Great. So I hope everybody were able to do this. Okay, so now we come with the questions that need words, and we're gonna start to think. So it says some water is stored in a bag. Let's draw this out. It's stored in a bag of porous material. So let me draw the bag here. And then we have some water in it. In some kind of container. Did they say it was in a container? Okay. Let's not put the container because it didn't say that in there. It just said it was in a bag. So I guess like what you see on those cowboy movies, when it's like in a satchel thing. Right. And I put the strap right here. So it's contained in a bag of porous material. Example canvas, which is hung, weighted, exposed to a draft of air. Explain why the temperature of the water is lower than that of the air. Anytime I ask questions like that under a certain topic, it has to do with latent heat or latent heat. Basically, it has to do with latent heat. Okay? So, I'm gonna get the answer for you. Hold a second, I have it written down. And the answer is actually present in these great textbooks. But I'm gonna be honest, this baffled me for a while because I never put any water in any type of canvas, nothing like that, you know. So okay, so here we go. It says an earthenware vessel has very narrow capillary bores within its structure. Water placed in such a vessel is attracted through the capillaries to the outer surface where it evaporates, drawing latent heat from the container and its contents in the process. So I'm going to write that down. It says an earthenware vessel has very narrow capillaries. With capillary bores. Within its structure. Water placed in such a vessel is attracted through the capillaries to the outer surface. Where it evaporates. Drawing latent heat from the container and its contents in the process. This sounds like how a fridge works. and its contents in the process. So basically, it removes latent heat. The material, the way it's built, it just removes the latent heat, therefore lowering the temperature of the water, or causing the temperature of the water to be lower than the temperature of air. Right? So you could add on that last piece. And the next question is, explain why a bottle of milk keeps better when it stands in the water in a porous pot in a draft. And that's pretty much the same answer as before. Again, the earthenware has capillary bores within its structure, which is able to cause the water to pass through those capillary bores, therefore removing the latent heat, lowering the temperature of milk, and stopping the growth of bacteria inside of that milk, or slowing it, and therefore keeping the milk longer, enabling the milk to last longer. So that's it for all of the possible questions I could have found for you or find for you. Not really, I don't have enough energy to find the right words, but I tried. I found 12 questions in which you could practice, because it's not easy. Thermal physics, the calculations are not easy. They only become easier with time. So I would suggest to you that you keep doing the questions over and over and over again until you become acquainted with it, especially the drawings and remembering when to put your phase changes in. Okay, so I hope that this helped you, and I hope that this has encouraged you to keep on studying. And with that, I say goodbye. Have fun trying the questions at least 10 times. Bye now.